starting into a new unit with Chapter 10, you're going to see this formula sheet within this week's Schoology folder. And this has area formulas as well as you can see the other formulas here. But what I want to point out is that when we start to talk about the lesson, which is going to be the first part of lesson 10.6, we will have bypassed over some other formulas that likely you've seen earlier on in your math careers. And I'm just going to point those out. So from lessons 10.1, 10.2, 10.3, and actually 10.5, so you'll notice I skipped over 10.4. I'll tell you about that in a minute. For the most part, they are some applications of some area formulas like area of a parallelogram, area of a rectangle. I'm going to jump over to area of a triangle because you've likely seen this before. You may have or would be able to use area of a trapezoid. So all of these, this 1, 2, 4, 5, these would have come about in sections 10.1 to 10.3. In 10.4, there's actually no formula on here from 10.4 because 10.4 is about ratios of perimeters and ratio of areas, which would relate mostly back to our chapter 7 when we talked about ratios, which is a way to compare two quantities. 10.5 actually has two things in it. This number 3, area of a regular polygon, and number 6, side angle side triangle area. So this is another triangle, area of a triangle formula, but we have to have a certain setup of the triangle. We have to know two side lengths and the included angle measure between them in order to use this formula. You're actually going to hear about this a little bit before we do lesson 10.7 because it does apply and can be used in some of our problems in 10.7. This area of a regular polygon, regular polygons have equal side lengths, equal angle measures, and this A stands for something called the apothem, and the P stands for the perimeter of the polygon. So, adding up the sides going around. We also have the area of a kite or a rhombus that's based on the diagonals in those figures, and we're going to come across the other things within the lessons. Again, this is available when you're working on practice problems or graded assessments. You should have this, even if you can only open it on your screen, you should have it ready to look at. If you can print it, it might be a good idea to print it as well. All right, so going over to the 10.6 notes and talking through. In this part of the video for the 10.6 notes, it's going to be a lot more just kind of like talking through the terms. So I'm not always going to read the whole thing. I'm going to jump down and kind of point out some parts to the circle. So you can see there's a lot, of kind of terminology within this lesson, and that's why it's going to be split over two different lessons, two different videos. You could certainly read through the definitions of these first things. I'm going to go ahead to this circle that is, in the middle of this page and talk about some of the things from the top that we see down here in the circle. So a diameter is a segment that has its endpoints on the circle and has to pass through the center of the circle. Right? There's actually something else that's not mentioned anywhere in this notes, but there are other segments that may be drawn. So I'm going to sketch it here in pencil. Let's say I had a segment from here to here in the circle. All right, this segment has endpoints on the circle, but since this segment does not pass through the center of the circle, it's not a diameter. We actually call this kind of segment here, it's called a chord, which if we were doing a few sections from chapter 12, we would talk more about chords. But just understand that, there is a difference in identifying something as a diameter, which a diameter is actually a chord, but a chord is not always a diameter. All right, you should already be familiar with, but I will just reinforce a radius from center to circle. PC is a radius, but so is PB, and so is PA. Notice too, the use of the segment symbol here. And then point P is the center of the circle. And something new to here is this central angle. A central angle is an angle whose vertex is the center of the circle. So we have to have the vertex at point P in this case. And for instance, angle APC is a central angle. But so is angle BPC. That is also a central angle. Right. So moving on, the thing that we're going to see more is we're going to talk about arcs and how they appear in a circle. And there's three types of arcs. There's the semicircle, the minor arcs, and the major arcs. And identifying them with a name and the symbol will help you know if it's a minor arc or major arc, or help the reader know that. A semicircle, you are probably familiar with, it is half of the circle. Which means in order to identify a semicircle, we're really looking for diameters. All right. Semicircles are named by 3 letters typically, and we use the arc symbol up above. Not a straight segment, it's not a segment, it's not an angle, it's an arc. Use the correct symbol. So in this over here, we use 3 letters, so arc TSR. You want to make sure that you follow the orders of the letters to follow your arc, TSR. Minor arcs. Minor arcs are smaller than a semicircle. They are named by only 2 letters. And the letters that we use as the name are the endpoints of the arc. So arc RS is a minor arc. Arc ST is another minor arc. If there were to be, let's say there was another point I put in here, let's just say I called it point A right there. If I wanted to talk about arc ST still, I still would name it ST. I would just bypass right over A. Because ST is a minor arc, we only need 2 letters, and those 2 letters are its endpoints. It doesn't matter if I say arc ST or arc TS, they are one and the same arc. Major arcs are larger than a semicircle. They should be named with 3 letters. Again, we kind of follow the order of the letters. So if we look at my example of arc RTS, R, we want to go in the direction of T because we want to hit T before we hit S. So RTS is a major arc. TRS is a major arc. Okay, and those were 2 different arcs. It's always helpful, even if you're working on practice on quizzes.com, you could draw your circle on paper, especially with this naming arcs or finding arc measures that we're going to talk about. This way you can trace the arcs. You can tell whether the arc is bigger than the semicircle or smaller, or is it a semicircle, all of those things. So there's an example down here. I'm just going to kind of make this visible. So you could pause the video, you could copy down the circle, you could copy down the names of the minor, major, and semicircles that I named. Also, one other thing, especially with the major arcs to point out, because I did already point it out up above with the minor arcs, if I take this major arc RSQ, so RS to Q, notice that I bypassed P because I don't want more than 3 letters to name the major arc. I could take arc RSQ, and rather than using the S, I replace it with the P. It's still the same arc, RPQ. So if you trace, you would still see that it's the same arc. Same would go for if I decided to say QSR. Doesn't matter, right? So be careful with that. Semicircles, we're looking for a diameter, and that's how I came about the semicircles that are there. All right, so let's talk about arc measures. When we say find the measure, whether it's measure of an angle or measure of an arc, We are always measuring in degrees in geometry class. So you want to keep that in mind. When you are finding the measure of a minor arc, a measure of the minor arc is equal to its measure of its corresponding central angle, and I'll point that out in a moment. The measure of a major arc can be followed by what is shown here. You take its related minor arc and subtract it from 360 degrees, the total degrees in a circle. But there's other ways to find it as well. A semicircle always has a measure of 180 degrees. All right, so here's a small example. Here is a circle, circle S. And notice that we have a central angle, angle TSR, which measures 50 degrees. To find the measure of a minor arc, which the minor arc is arc RT here, notice that the central angles sides that extend out, which happen to be radii of the circle, where they end at the circle, they enclose this arc RT right here. So this measure of this minor arc has to be the same as its corresponding central angle, so 50 degrees. There is a major arc here, arc TQR is a major arc, and knowing that we know RT, we can take the total degrees in the circle, 360, and subtract the 50 degrees that we found to be arc RT right here. All right, and that's 310 degrees. There is also something, and this should relate back to some of the very first days of geometry when we talked about maybe adjacent angles early on, even adjacent line segments. Adjacent arcs are arcs of the same circle that have exactly one point in common because they're right next to each other. All right, there is a postulate, and again, this postulate can relate back to some of our very first days in the course when we talked about segment addition postulate or angle addition postulate. This is arc addition postulate. It allows us to add together two neighboring arcs to get the measure of a bigger arc that they form. All right, so we can always add those together. It might just be a pair of arcs, or maybe there's even a third arc in there. All right, so the arc addition postulate. All right, so there's some various measures here in this next one that kind of look at this, and I'm going to cover up some things while we talk about it. Find the measures of the arcs. All right, so I'm going to name some, and one of the things I'm going to point out first that you can see some of my writing over here is that we have a minor arc, arc PR right here. We expect a minor arc to be less than 180 degrees, and it makes sense because its corresponding central angle, angle PCR, is 77 degrees, so this arc should also be 77 degrees. Another minor arc is arc RS, and what we see here, and this doesn't always jump out at you, notice that PS, segment PS, is a diameter. You always want to keep an eye out for diameters because then you know you have a semicircle. So in semicircle PRS, that is 180 degrees. That's how I could come up with the measure of arc RS. I do 180 minus 77. Let me show you some others that I have written down here. So there are some other arcs. So we talked about PR, we talked about RS with locating that semicircle. Let's look at a couple major arcs we have. So measure of PRQ, PRQ. This may be one, being that we already have PR and RS, and we have written down QS, we're just kind of using arc addition to add these three adjacent arcs together. So that's one way that you could find the measure of arc PRQ, not the only way. How about the measure of arc PQR? Remember to kind of trace in order. So PQR, it's a pretty big arc. all right, going from P, passing by Q, and having another endpoint at R. And what we notice is that we've passed by much of the circle except for this 77-degree minor arc. So we can take the total degrees in the circle, subtract out the 77, one way to do it. Right, again, as you're practicing, it would really be helpful to have, paper and pencil there and try to sketch the circle down on paper so then you can better trace and find your arc measures when asked to do so.